Good morning, everyone. I am Rupam Das. I just completed my MSc degree from West Bengal State University in Electronics branch. And I am very much thankful to ICMSME and Regents Institute for giving this opportunity to present my work on designing and analysis of Arduino-based heart rate monitoring system using photoplethysmographic sensor with MATLAB signal processing and IoT applications. This project also gives numerous ideas about the IoT applications regarding the serial data transmissions via Bluetooth, Wi-Fi, and GSM support. And our next slide is heart rate and pulse rate. So before entering the ultimate methodology, we have to know the basic difference between heart rate and pulse rate. The human cardiovascular systems consist of blood vessels, heart, and approximately 5 liters of blood. The heart rate is basically the soundness of human heart. That is nothing but the speed of heartbeat measured by the contractions of the beat per minute. And the other hand, pulse rate is arise due to the ventricular systoles of heart, by which the blood is pumped out throughout our body, and some particular positions known as the pulse point in our body. The simultaneous volumetric change of this blood flow per unit times can be detected as pulse rate. And this is the basic difference between the heart rate and pulse rate. And we'll go to the next slide. This is photoplethysmography. And these terms, it is the optical terms, and this is the heart of our project. Photoplethysmography is an optical phenomenon which comes from two ancient Greek words, plethysmos and grapho. Plethysmos means the increase and grapho means right. In any type of PPG technique, the biological tissue have to be illuminated by an incoherent light source, like I would say IR signal and any other blue or green light. And the power of the light is either transmitted or reflected from the tissue is measured by the photosensor. In our purpose, we measure the volumetric change of the blood at the pulse point flows per unit times at any pulse point by using this technique. But we have to point out that the PPG, any type of PPG signal contains two components, AC component and DC component. AC component corresponds to the variations of arterial blood volume in synchronizations with the heartbeat, and the DC component consists of the informations of non-synchronous tissue, venous blood, and non-pulsating arterial blood. So we need filtering. And after some next slide, we briefly discuss the filtering. And our next slide is the making of pulse sensor circuit fabrications. Here we also developed a manual PPG sensor or photoplethysmographic sensor by using an IR technique. This sensor makes use low intensity IR LED photodiode, and instead the IR LED we can also use normal green LED. And if we place this LED and photodiode side by side, the radiation from the LED is transmitted. The LED is emitted, the radiation is emitted and is detected by the photo detector. And if we place our finger in this method or in this method, between as an obstacle between this IR receiver and photo detector and IR LED, the pulse should be detected, as the volumetric change of the blood flow can be detected. And we will go to the next slide. This is filtering. As per the early mentioned, in the synchronized PPG signal, the DC component is arise as the optical informations of the tissue, venous blood, and non-pulsating blood. So we need filtering to cancel out this DC part. And we also use this filtering to remove the unnecessary noise and allow only the desirable bandwidth to our sensor. And we develop an second order bandpass filter in our manually generated circuit to eliminate this DC part. And after filtering, we get this type of PPG signal. In this is the our in lab that this is the DSO configuration, and we get this filtered PPG signal. And after that, we come to our next slide. This is the measurement our heart rate using an Arduino, which is the basically a microcontroller. The pulse sensor 11574 is used to acquisitions of the signal from the persons whose heart rate is to be measured. The pulse sensor is attached to our finger from which the values are to be acquired. For this purpose, a low-cost Arduino microcontroller has been used with the 80 mega 328P microcontroller IC. And these Arduino read the analog values of the signal from the pulse sensor and convert it into the digital manner for further processing. This is ultimate the flowchart of the total process to collect the heart rate value. And this is our last slide. It is the basically IoT applications of our project. IoT means the Internet of Things. By using internet, we can transmit any types of data by cloud system or GSM system, and any types of local area network communications like Bluetooth, Wi-Fi. And in here, the heart rate informations need to be displayed and transmitting via Bluetooth. And we need the monitor a patient virtually. So we need this transmit this data. And for this purpose, we use the HC05 Bluetooth module and Bluetooth terminals mobile applications to monitor our patients virtually. And HC05 module is used as the data transmitter, and the Bluetooth applications, these Bluetooth terminal applications, used as the data receiver. And this was our total work on the optomechanical integrations of heart rate in the pulse sensor. So I am very much thankful to all of you